Hello, this is session 7, video number 6. In the previous video we began doing the simulation on the design, and in this video I will continue with the simulation. So I had the test bench here and I updated the test bench. It had a problem with T-Ready. T-Ready is now, the problem with T-Ready is fixed. I come back here to my to the Vivado environment. I press run simulation and we want to do behavioral simulation. Okay, now we have the simulation environment, and I push these guys a little bit this side and also these guys a little bit this side, and here we have in fact the name of the signals and the waveforms, and it has done the simulation for us for 1000 nanoseconds, and I can continue, for example, 3 microseconds. So total I think 4 microseconds we have done the simulation, and these are the waveforms, and we can analyze the waveforms and see if in fact the design is behaving as expected and what is wrong, and then we can go and fix the thing which is wrong. So I just try to make suitable area for each of the components, and then I zoom out, and when you zoom out actually you see your waveforms. And let's see if I can have a so here is the story that we have, and let's first have a general look at the design. So what I have, let's have a look at for example our master interface. What do we have in the master interface? In fact, we have the data. The data is flowing. It looks, it is always changing, so it looks fine. In a very broad view it looks fine, it's always changing. Then we have the T-last. T-last is coming, so I have not yet gone into details. I'm looking overall at my waveforms, and I see T-last is coming, and I say okay, as a first general look it is fine, so there is something there. Then I look at T-Ready, and I see that my module is showing suitable reactions to T-Ready. Look here, look here. When T-Ready has gone down, I see the data is no more being sent. There is no T-last. There is no flow of data. Data is not changing. So generally, overall, when I look, it's fine, it's working. Then the T-strobe is always 1. It's fine. I want it as it is. And then we look at T-valid, and actually T-valid is also behaving fine, because as you remember, the only one who was responsible in fact bringing down the T-valid was the in fact the enable signal. And as you see, the T-valid goes down only when enable is not active, and the T-valid is always, in the rest of the situations, the T-valid is active. So overall, when I look at my design, I find it something convincible. I think overall the design is working, but you should be always very accurate when you are designing at RTL. Then every single cycle is important. So I think what we need to do is we need to go a little bit deeper, and for example make sure that every packet really contains, what was the frame size? It was 16, so we should make sure that every packet contains 16 in fact pieces of data. These are important, so we should make sure T-last is happening at a suitable time. So what I do, let's zoom in to one of these guys, and I don't know, yes, No, how the ZYNQ waveform viewer zooms. Oh, ooh, yeah. I have rarely been working with this mess there. I have always been working with VCS, and okay, VCS is lovely. I have shown you before the VCS is the best simulator I have ever seen. It is light, it is powerful. For example, NC sim of cadence, it is powerful, it's extremely, I would say, robust NC sim, but it's not light, is a big load for the system. But VCS is light, but is really powerful, is robust. It has all advantages all together. Okay, anyway, here let's count, in fact, how many data is being transferred and see if this guy is correct, or it should be sooner. I don't know. Okay, so what should I count? Actually, I should count the number of data which is being transferred. So for my counting, I need this clock. I need to move this clock somewhere, for example, somewhere meaningful, beside t valid. Where's t valid? T valid is here. I put it here. And where's t ready? Let's put t clock, t valid, t ready, and then finally let's put t last. Okay, and I'm now doing this. It's not good. The way that I'm doing this is not good. It's not polite. You should really arrange your waveforms in correct order. But for now, okay. So t valid, t ready. When I look at t ready, what I see in this duration, the t ready is always equal to 1. I don't see any change in t. So practically I will be counting, in fact, this is the first clock cycle. So actually if you look at the data, t data, you see the first clock cycle is happening. T data has been 0 here, it has got 1 here. First clock cycle, second, third, fourth, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and so what I conclude is t last is coming 1 cycle late. In fact, with this clock cycle, with this edge of the clock cycle, the receiver module should also see t last, because this is the last data of this packet. Yes, every packet should contain 16 pieces of data. If I count again, 1 piece, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And this is the last piece of data being transferred for this packet. So along with this edge, I need the t last to be activated. But t last is 1 cycle late. And what I think with myself is that in the design, so let's close the simulation. So we have found a bug, and actually I'm using very simple methods to analyze my design. And as you know, when your design gets bigger and bigger, these simple methods, they don't work. Counting cycles on the waveform like what I am doing, it doesn't work. And there are methods to do that. And actually it is one very active field of chip design for itself, verification. But this is not something I want to address in these videos. That is its own field of study. So here I close this file. I close this file and I open the main design file, and you should not open the file, the Verilog file that is copied by Vivado into your project. You should open the main design file that you have there in the IP repository folder. So it will be inside my course, then inside IP repo, and then sample generator, HDL, and I need this guy, I need this master. Okay, so okay, and here the TLAST, I think probably if I enable TLAST 1 clock cycle earlier, that would be better. So I change it from -1 to -2, and I save it. And now what should happen is that I have updated something here at my IP side, and I should make Vivado to update it as well at its project side. So let's try the reset option that I described to you in the previous video. Here I come, design, and something has changed inside the block diagram. So I say reset output products, and what has changed practically is not the interfaces of the module, it's not the parameters, it's not the module definition, but it's something internal to the module. Okay, because sometimes if you are changing the interfaces of the module, then your block diagram is no more valid. Okay, indeed I have the block diagram. Let's open the block diagram so that I can complete my descriptions. Oh, sorry, I was looking for the block diagram. Yes, this is the block diagram. And when I in fact right click on this guy, I have the option edit in IP packager. And for example, when you change the ports of your block, change something principal about the interfaces of the block, then the block diagram should change. But when you change the source code internal to the block diagram doesn't change, and we don't need to run this edit in IP packager. But here, if one port is changing, I may be able to run edit in IP packager, then repackage the IP, then that project will get closed and this guy will get updated. Okay, but usually this is one solution. So if the ports are changing, this is one solution to update your block diagram here. But usually what I do, since I'm creating TCLS scripts for whatever I do here, usually what I do, I just run the TCLS script again, and my block diagram gets created in few seconds. So you have these two solutions. But right now, by the way, I think it will kind of solve our problem if I reset output products. Yes, you should wait. Yeah, reset output product, reset. And yeah, and then now, yes, and then now regenerate in fact output products. So generate output products, generate, yeah, not important. Okay, let's double check if the new changes are appearing inside our Vivado project. So I come out of my course folder, I go to Vivado folder, and inside Vivado folder I go to project 2, and inside project 2 I can find every Verilog file that I have here, and I should look inside this file and I should see my change there. Yes, So let's see if it is there. Yeah, it's not, and that is bad and is not good. So reset output products is not working. So if this is the case, what I need to do is I need to repackage the IP again. So let's my course and open the Vivado project related to my IP block. Or one other thing that I can do, I can come here, edit in IP packager. So yes, I had never seen this before, because as I told you, I usually run the TCL script from scratch. I create the block diagram from scratch. Anyway, when you change anything about your design, you should repackage your IP. So I repackage IP. Okay, now let's do it again. Reset output products. Reset. Yeah, now generate output products. And now let's do the check again. So verilog files, and inside my core, inside Vivado project 2, and we have now in fact two sets of folders, and Vivado is using just one of them. So let's have a look at, I think, the one which is newer, the one that we had before, the one that is newer. I will look at this one. Okay, now it is applied. So whenever you change anything about your design, you should repackage your IP. Run simulation, behavioral simulation. Okay, now we can do again the test to see if the issue is solved. Anyway, this is the procedure through which you test your design, and you can test your small blocks using this technique, and then your big designs will be in fact your small blocks joined together. So here I think should have it, so maybe I better not to waste time. So you have t valid and then the edges of the clock, t valid, edges of the clock, and you have 1 edge, 2 edge, 3, 4, 5, 6, 7, 8. Yeah, for with the final piece of data you have the t-last active. Then okay, this is our design. It's kind of working. It's satisfactory for now. Maybe there are more bugs, but I think for now is enough. And we can continue to the rest of the design when we are sure that our block is kind of working and is usable. So this is the end of session 7. I will not continue any video parts for session 7, and we go, actually session 8 is already there. We go to session 9, and in session 9 we will talk about the SDK environment and how you can use the SDK environment and you can write simple programs which will be executed under the ARM host. Our main target, in fact, will be to program one AXI DMA module. As I described to you in previous sections of the video, when you have your, in fact, AXI Stream blocks connected to each other, you create a pipeline, a data processing pipeline, but eventually the output of this pipeline, it should go to the ZYNQ PS, and it should be stored on the DRAM of the ZYNQ PS, so that your ARM host there can read that data and